Hello, welcome back. Today let's solve Leetcode problem number of provinces. So we have n cities and some of them are connected while some of them are not. If a city is connected directly if city A is connected directly with city B and city B is connected directly with city C, then city A is connected indirectly with city C. Okay, makes sense. A province is a group of directly or indirectly connected cities and no other cities outside of the group. Okay, uh, so we need to return the total number of provinces. So the input we have an n times n matrix is connected. Okay, that represent for if the city I is connected directly with city J or not. If it's connected, so their value is 1, otherwise their value is 0. Okay, so it makes sense. Okay, so let's check for the example 1. So for example, we have city 1 is connected directly with city 2, while city 3 doesn't city 3 isn't connect with any cities. So we need to return 2 because there are two provinces, right? City 1 and city 2 are one province and city 3 is one province. Okay. uh, okay, and for the example 2 we have three cities, but uh, they do not connect each other, so we will return 3. uh, okay. uh, okay, I think this problem is very straightforward and the solution is also straightforward as well. Okay, we just need to apply the deep first search algorithm, right? Because we will need to do the deep first search for every city, and okay, so if we finish the deep first search for each city, it means we already found one province. Okay, and if we can do the deep first search for n city, so we can able to find all the possible province, right? So yeah, I think it's very straightforward. uh, okay, so let's try to code it since there is no more problem. Okay, so let's try. mm, okay, and okay, so let's uh, declare a variable for the answer and then finally return the answer. So as I mentioned, we will need to do a for loop. uh, I equal to 0, I less than is connected dot length I plus plus. Okay, and what we do, we will try to DFS. uh, we will try to DFS the CTI, right? And then when we finish DFS for uh, the CTI, it means we can uh, we already found all cities that belongs to that province, right? So we will increase the answer. Okay, so that the prototype is very simple, right? So our task now is only need to implement the default search algorithm, right? A private void default search. Okay, so we have int rough and in okay city. Okay, and okay, so to for the deep first search algorithm, we will need to declare a stack, and then we will try to visit all possible neighborhoods, right? Okay, so let me remember how to implement DFS. Okay, so let's try to declare a stack. Okay, integer stack is new array dq. uh, okay, okay, and then we will start with the city and then stack dot of first city. Okay, and why not stack is empty. What we do, we will get the current city. Okay, current city is stack dot pound first, right? Okay, and uh, we will uh, we will ignore. Okay, we will skip for this city if it's already visited, right? Okay, so let's declare an array that to mark if the if that city is already visited or not visited. Is new boolean is connected dot length. Okay, okay, and okay, and here we only do the default search if the if that city is not visited in the past. uh, if if not, right, if not visited I, and then we will dfs I, then okay. We also need to pass the visited array to the default search method as well. Boolean visited. Okay, and if if visited at current city, okay, we will ignore it, right? Continue. Okay, and then we will mark the current city is visited. The current city is true, and then we will try to add on adjacent cities into the stack for the next uh, action, right? Okay, so we will have int adjacent cities. Okay, and the cities equals to graph at current city, current city, and then we will put it to the stack if and only if the adjacent city if it connect directly to the current city, right? And then we have for I 0 I less than adjacent cities dot length I plus plus, and if adjacent cities at I equals to 1, right? 1, it means it's connected. So we will push we will push uh, the the adjacent city to the stack, right? It means we will put stack dot offer first I. Okay, so I think that's all for the implementation. uh, okay, I think that's all. Let's try. Okay, it looks good. Okay, and now let's submit. Okay, accept.